Hello and welcome. In these diagrams, we are looking at the architecture of two different microservice based applications. These are the same applications we have explored in our cloud and DevOps video series, where in part 1, we deployed the application on the left side to Amazon Web Services AWS. This application mimics a basic social media platform, allowing users to create messages referred to as posts and add comments to them. Each post and comment represents a unit of data that needs to be stored in a database and later retrieved for display. This application demonstrates how microservices handle the creation, storage, and retrieval of data, showcasing their communication flow and orchestration. Once a post or comment is created, it is saved to a database and then fetched for rendering on the front end. And in part 2, we deployed the right-sided application to Google Cloud Platform GCP. This application simulates a real-world features such as status checking, messaging, user authentication, email processing, and logging. These microservices are designed to communicate internally and also interact with external clients such as web browsers. The focus here is to showcase inter-service communication and integration with outside systems. So far, we have explored how these two applications can be deployed on two major cloud platforms, AWS and GCP. Now, let's shift our focus to deploy these two microservice applications in an on-premises setup. Instead of hosting them on remote cloud platforms like AWS or GCP, we will deploy them on a dedicated physical server. In this case, the Linux-based PC we are using to record this video. This setup represents a real-world on-premises environment where organizations may choose to manage and host their applications on internal infrastructure rather than in the cloud. Let's take a look at how the architecture for this kind of on-premises deployment would look. As shown in the diagram, this architecture mirrors what we aim to build in our local environment. Let's quickly walk through the components of this setup. Here we can see at the center, we do have our Linux-based PC with which we are recording this video. Will serve as the dedicated server for hosting both microservice applications. Here we can take a look at the basic configuration of our Linux server, which is in this case our Ubuntu-based PC. Settings, system, about. From this section, we can view the system specifications such as processor, memory, then operating system. Here we can see the processor Intel Core i3, 7th generation, 4 cores, memory, 8 GB. Hardware model we can see, then operating system Ubuntu 24.04.2 LTS version. So system details. So from here, these specs define the capacity and performance of our on-premises server. Based on this hardware configuration, our Linux server is capable of supporting up to approximately 50 concurrent users, which is sufficient for lightweight microservice applications in a development or small scale production environment. However, if the number of users accessing our application exceeds the current capacity, we will need to upgrade to a higher configuration server. The decision should be based on actual performance metrics, which can be gathered through a monitoring stack, something we have already covered in our cloud and DevOps video series, especially with part 2. We are referred to those videos to learn how to monitor application performance effectively. Now let's explore some potential hardware upgrade options. Let's search for server price in Bangladesh. Let's go to the website of Ryan's Computers. Here you can see the options. Let's see this sixth one. We can go with like this one. See the configuration. Intel Core i7 14th generation processor, speed up to 5.40 gigahertz. Then processor cores 32 GB of RAM. This is a significantly more powerful choice for heavier workloads and larger user bases. Let's see more higher configuration. Let's go to the second page and see the last one. See what we have. Here we can see this one, the last one. This is a rack mounted server, typically used in data centers or warehouses. This one features an Intel Xeon Gold processor with speeds up to 4 gigahertz, 48 cores, processor cores, that's quite huge, and a massive 512 GB of RAM. This is ideal for enterprise scale deployments. So depending on the demand and expected user load, we can select a server that meets our performance requirements. For now, our current configuration is more than sufficient to handle up to 50 concurrent users, making it well suited for development, testing, or even small scale production. So let's proceed with this configuration. Before moving forward, let's briefly discuss why we are using a Linux-based OS like Ubuntu on our machine instead of Windows. Here are the key reasons. It's lightweight and efficient. Linux doesn't come bundled with unnecessary GUI components or background services like Windows does. As a result, it consumes far fewer system resources, CPU and RAM, making it ideal for server environments. Then it's free and open source. Unlike Windows, official Linux distributions are typically free to use and open source, eliminating the need for licensing fees. Then it has a stronger security model. Linux benefits from its open source nature, allowing vulnerabilities to be identified and patched quickly. It's widely regarded as more secure by design compared to Windows. Then it has greater control and flexibility. Linux provides full control over the environment, including system level configurations. Windows, by contrast, tends to be more restrictive, often requiring official tools or GUIs for customization. Then it has better support for web and DevOps tools. Most modern tools such as Nginx, Apache, MySQL, Docker, Kubernetes, and others run natively and more efficiently on Linux. While Windows can support them, performance and compatibility may be limited. Then it has long-term stability. Linux servers can often run for years without needing a reboot, maintaining stable performance over time. Windows servers typically requires periodic reboots, especially after updates, and may experience performance degradation if left running for extended periods without rebooting. Then it requires minimal hardware. Linux can run efficiently on older hardware. We can install it with just 4 GB of RAM, 25 GB of SSD storage, and even on older generation processor. This makes it accessible to a wider community and particularly attractive for developers. So, because of all these advantages, Linux is the preferred choice not just for our on-premises setup but also in cloud environments. In fact, when we launch virtual machines on platforms like AWS or GCP, Linux is the default OS in most cases. So now we understand why Linux is the ideal choice for our server environment. With that in mind, let's move forward with this setup. So we do have our PC, which serves as the physical hardware. Now inside of it, we need a Linux environment to effectively transform it into local Linux server. And this we have already done by installing Ubuntu Linux in our PC. Let's cover the Ubuntu installation process later. And then inside of this server, we will have a Minikube installed, which will provide us with the required Docker containers to create necessary nodes with the help of our PC's OS kernel to host and run necessary local Kubernetes cluster. Since this setup runs entirely on our local machine, the Kubernetes cluster will be private. It will not be exposed to the public internet and won't use a public IP, making it more secure by default. And then within this private Kubernetes cluster, we will have Kubernetes control plane or API server, which will help us to manage the app resources. Here we can see the app resources for our microservice applications, pod, then inside of it there will be services to access the pods, then here's ingress to expose our app resources externally outside of the Kubernetes cluster. So these are the app resources which we can manage with the help of this Kubernetes control plane or API server by making kubectl request locally from our PC or server's integrated terminal. Then there will be necessary local firewall rules configured and applied from the system, which will control, allow or deny all inbound and outbound requests and responses. Means all the traffic's coming and going through the router and the internet from the browser to our hosted deployed application, hosted or deployed application in our local Linux server. Now, as shown here, our local area network LAN is connected to the wide area network 1. In other words, the internet via an Ethernet connection using our router and the internet service provider ISP. This setup allows our system to communicate with external networks while still being part of a secure internal local network LAN. However, when it comes to deploying and accessing our application locally, especially for testing and debugging purposes using a browser, we don't need to go through the router or access the internet. In this case, all traffic stays within the local environment, allowing us to interact with our application entirely within the LAN or even on the same machine without routing it externally. Now, when it comes to deploying and accessing our application globally, we will need to configure some additional network settings, especially with our router. To expose our application to to the external internet, we must obtain a public static IP address, either IPv4 or IPv6, from our internet service provider ISP. By default, most ISPs only provide private IP addresses that connect our local area network LAN to the wider internet one. These private IPs are not reachable from the outside networks. So in this case, we need to request and reserve a public IP from our ISP. This public IP will allow our application's domain name to resolve to a reachable address on the internet. This step is crucial for global access because we will need to add a DNS record, a record if IPv4 or quad a record if IPv6 in our domain provider settings, for example, Squarespace in our case. So we need to add a DNS record that points to the public IP which we reserved before from our ISP. Once we have the public IP assigned to the one interface of our router, the next step is to configure port forwarding. Here we can see we have provided the port forwarding rule here. So the next step will be configuring the port forwarding. This tells the router how to direct incoming traffic from the internet, to our internal application hosted on our PC instead of the local area network LAN. Now let's see how can we set this port forwarding rule using our router settings. To access the router settings, let's first identify the private LAN IP of our router. On our Ubuntu PC, let's go to settings, then network, then under wired network options, and here look for the DNS field. Here in our case it is 192.168.0.1. That's the router's internal IP. Let's copy the IP. Now open up our browser and enter the router's internal IP to access the router's web UI locally. Let's provide the default username and password. Here we can see the status of our router, the current status of our different connections here. Local area network LAN, then wireless network, and then the wide area network 1. Now let's set the port forwarding rule. Let's go to the forwarding section, select virtual server, then click on add new to create a new rule. Now let's configure the forwarding rule. For the service port, we'll use 443. The standard HTTPS port, this is the external service entry point. And then for IP address, we'll use 192.168.0.103. This is the LAN IP of our Ubuntu host where Minikube will run, effectively our local app server. Let's find that from our Ubuntu PC. Here you can see under wired, under the networks settings, there's IPv4 address. So this IPv4 address, this one 192.168.0.103, this IPv4 address is the LAN IP of our Ubuntu host where Minikube will run, means our app server will run. Now for internal port, we'll use 30935. The node port assigned by the Kubernetes to our front-end service. This port forwards traffic to the internal container port of the application. We'll use a node port type for our front-end service. And after deploying the app, we can view the assigned node port using kubectl get svc, means service, which we'll then use as the internal port in the forwarding rule. For protocol, we'll select TCP. Then the status will be enabled. And lastly, for common service port, we can select HTTP from here or can leave it unselected. Let's leave it unselected. Then finally, let's save the rule. So the forwarding rule has been saved successfully, and we have created the necessary virtual server on our router. Now, once we have a public IP assigned to the one interface of our router, any incoming HTTP request to that public IP, such as from a domain we configure, will first hit the router. Now, as the port forwarding rule is set up on our router here, the router will forward that request to our Ubuntu host LAN IP on the node port 30935 we exposed from our front-end service. From there, the traffic is routed to the container port of the application inside of the Minikube cluster. So by configuring this forwarding rule, we enable external internet traffic to reach our locally hosted microservice running inside of the Kubernetes in our local on-premises setup. And here in this setup, we can see for all inbound traffic from the external browser to the app resources in the Kubernetes cluster inside of our server, first request and then response completes the inbound traffic. So for all inbound traffic, and then for all outbound traffic from the Kubernetes cluster to the internet for pulling Docker images in time of deployment, first request and then response completes the outbound traffic. So here for all the inbound and outbound traffic, the router is directly involved. So this concludes the overview of our on-premises setup. Now that we have a clear understanding of the architecture and its components, we can go ahead to achieve this setup. But before we proceed, it's important to highlight a critical consideration, and that is there's a significant security risk associated with this setup. This on-premises architecture involves exposing a public IP to the internet in order to make our application globally accessible. Doing so introduces potential vulnerabilities, and securing such exposure requires several additional layers of protection, such as robust firewall rules to control inbound and outbound traffic, DDoS protection to defend against distributed denial of service attacks, advanced threat detection and mitigation systems, regular security monitoring and patch management. Even with all these security measures in place, it can still be challenging to guarantee complete protection when operating from a local self-managed environment. So while this on-premises setup is functional and educational, it's not currently a fully secure solution for global application deployment. Security should always be carefully considered and addressed, especially when exposing services to the public internet. So we can't proceed with this insecure setup. Now, to achieve a secure on-premises setup and deployment, we can utilize a service called Cloudflare Tunnel provided by Cloudflare. Here we can see the architecture diagram of our secure on-premises setup using Cloudflare Tunnel. Here we can see the tunnel. These tunnels are persistent objects, essentially lightweight configuration files, often in JSON or YAML format, that contain credentials and routing information used to establish a secure connection between our local server and the Cloudflare's global network. Now here the tunnel is created using Cloudflare's CLI tool called Cloudflare, executed from server's integrated terminal. Once configured, the tunnel securely connects Cloudflare's edge network to the exposed service ports on our local server, typically of type node port or load balancer in Kubernetes setup. So this was about the tunnel and how it creates and connects. Now let's try to understand what happens when there's any request are made by the client. Client request from the internet are routed to the Cloudflare's edge server. The edge server acts as a reverse proxy, forwarding the request through the tunnel to our local backend server. The backend server processes the request and sends the request back through the tunnel to the edge server, which in turn delivers it to the client. So here we can see the entire communication flow eliminates the need to expose a public IP, where Cloudflare's edge network serves as the public facing endpoint, not our local server. So here in this setup, the tunnel handles all inbound and outbound traffic to and from our application. And then the router's involvement is minimal here. It only plays a role during the initial outbound request when tunnel is established. Unlike the insecure setup where the router was responsible for both inbound and outbound, traffic, here with the secure setup, that responsibility is shifted to the Cloudflare tunnel, which adds a robust layer of security and abstraction. So this is the Cloudflare tunnel, which provides a secure and reliable way to connect our private on-premises server to the internet without exposing it through a public IP. For more information, we can visit to this official Cloudflare documentation for the Cloudflare tunnel. We can see overview, get started, downloads. It's worth reviewing this in detail when we have time. So with this Cloudflare tunnel in place, this becomes the final secure on-premises architecture that we aim to implement for hosting and deploying our scalable distributed microservice applications. Now let's proceed with this architecture and start setting up the environment step by step to deploy and host our applications securely. To set up our Linux-based server, we will begin by installing Ubuntu LTS, the most widely used and stable Linux distribution. We can download the latest LTS version for desktop from this official website. From here, we can download the Ubuntu LTS. The latest version is 24.04.2. So from here we can download the Ubuntu LTS. Installing Ubuntu is straightforward. We can see the system requirements. It's 4 GB memory, 25 GB of SSD or hard drive. So installing Ubuntu is straightforward, and there are plenty of detailed guides and tutorials available on YouTube if we need assistance. Let's quickly give an overview of the installation process. The quick overview of installation process. First, download the Ubuntu LTS ISO file for desktop. Then use a tool like Rufus to create a bootable USB drive. Then insert the USB into the PC and restart it. And after that, enter the boot menu, usually by pressing F12, F2 or ESC depending on the motherboard. And then finally select the USB drive and begin the installation. And during the installation, choose whether to dual boot Ubuntu alongside the existing OS or perform a clean installation, which is recommended for server use. This clean installation will erase the current OS and install Ubuntu as the primary operating system. The clean installation is generally more stable for this kind of server environment and avoids any disk partition issues later on. So once the Ubuntu is installed, our PC will be ready to function as a dedicated Linux server. Now in our case, we already completed this step, and as discussed earlier, we are going to use this system as our local server environment. So we have already set up our local server environment. Now it's time to set up local Kubernetes environment. To set up the environment, we will need a Minikube node, which will provide us the Kubernetes cluster locally. Now to have the Minikube node and run it with Docker container, you will have to install Docker engine and then Minikube. And here the Kubernetes cluster will come pre-installed with the Minikube. And then in the Kubernetes cluster, we are going to have this Kubernetes control plane or API server. So let's install Docker engine first and then Minikube. We'll open up our browser, then we'll install Docker engine first. Install Docker engine. Install Docker engine. For Ubuntu, we will install using apt repository. Set up Docker's apt repository, copy the commands, open up terminal, then simply paste all the commands, hit enter, then provide the password. Done. Setting up Docker's apt repository, then install Docker packages. Latest. Copy the command to install the latest version of Docker engine. Paste. Hit enter. Yes. Do want to continue. Done. Now let's verify the installation. We can run this hello world Docker image, but we won't. Let's simply check the version, Docker version. Here you can see, nice, we have successfully installed the Docker engine. Docker engine community. So the Docker engine installation is done. Now let's quickly install Minikube. Install Minikube. Operating system Linux, architecture 8664. Release type is stable, installer type binary download. Let's go for it. Copy the commands and open up terminal. Go for the installation. It's done. Now we'll not start Minikube right now. Let's check the version directly. Minikube version. Nice, you can see we have successfully installed Minikube. Now that we have installed both the Docker engine and Minikube, we can now run the Minikube node as a Docker container to host the Kubernetes cluster pre-installed with it. And after we host the Kubernetes cluster, we will be able to deploy our application to this Kubernetes cluster. We'll go for this, but before that, let's prepare the necessary environments and have the prerequisite first. Now here we can see the kubectl client is still needed to be installed. So let's install that. Open up browser again. Let's search for install kubectl, install tools, Kubernetes tools. Here's install kubectl on Linux 8664. Download the latest release with the command. Copy the command. Now paste it in here to install kubectl. It's done. Now step 1. Step 2, validate the binary. Let's validate, though it's optional. Now if it is valid, the output will be kubectl OK. Let's paste. Nice. Here we can see it is OK. So in step 3, let's finally install the kubectl. It is done. Now let's check the version. Nice. Here you can see client version 1.33.2, customized version 5.6.0. So we have done installation the kubectl. Now that we have installed Docker engine, then Minikube, which will provide Minikube node with Kubernetes cluster to run as a Docker container, and then kubectl client, which will provide the Kubernetes CLI. So our local Kubernetes environment is fully set up, and with this we have also done setting up all the components of our local server. Now that our local server environment setup is ready, it's time to configure GitLab CI/CD to automate the deployment process of our applications. To enable GitLab CI/CD, we will configure a GitLab runner on our local Linux server. This runner will monitor our GitLab project and execute the pipeline jobs defined in our .gitlab-ci.yml file. So let's go for setting up the GitLab runner for executing CI/CD pipeline. In our GitLab here, we can see we do already have our existing GitLab project named On-Prem Go Microservice app. This project already contains our application code, we can see, which is ideal, but even if it didn't, what really matters is having a GitLab project created. The CI/CD process depends on this repository to trigger automated deployments. Since we already have this project set up and ready, we will proceed with it instead of creating a new one. Now for the CI/CD settings from our project, GitLab project, let's go to settings, then CI/CD, then expand this runners section. Let's disable the gear icon for instance runners to avoid confusion, since we won't be using shared runners. Now click on create project runner. Now let's create and configure our project runner from here. Enter Docker as tag. This will help match jobs with this runner. Now in here, for runner description and maximum job timeout, we will leave these blank as default. These are optional. Here we can see. Now let's create runner. Now we can install and register the runner on our local machine by following these provided steps. So let's follow the steps and do that. Platform operating systems, Linux is selected. Now GitLab runner must be installed before you can register a runner. How do I install GitLab runner? To install GitLab runner, click on that, select platform specifications to select the GitLab runner, AMD 64. This is okay. Now copy all the commands to install the GitLab runner. We'll open up our terminal. Now we'll paste all these commands. Now we'll hit enter. to install the GitLab runner. We'll provide the password. We'll provide again. Now it's okay. Now it's installing the GitLab runner in our local Linux environment. So we have installed the GitLab runner in our local Linux server. Now after this, copy and paste the command into your command line to register the runner. Now we will register the runner. We'll copy this command in our terminal. We'll use this command to register our runner. Now with this command we will use sudo to register it with our default root user on our server. We can run the command without sudo as provided here and can register the runner with a specific non-root user. If so, then we will have to create and switch to that non-root user in our CI pipeline which we are going to run. This won't be an issue, but it can be an issue to switch from the default root user in time of managing the resources through kubectl client. That can create confusion. So let's register the runner using this command with sudo. Type sudo and space. Now we'll register the runner using this command with sudo to register under the root user. So let's hit enter to register. Now we'll provide the necessary informations. Here we will provide the GitLab instance URL, which is this one. Copy, Control Shift C, then paste, Control Shift V. Now let's hit enter. Now here we'll name it as GitLab runner 1. GitLab runner 1. Hit enter. Now we'll select Docker. Here we can see Docker. Let's copy this one. Copy and paste. We'll select Docker as executor. This happens to be the same value as the tag we provided earlier in GitLab here when creating the runner, but that's purely coincidental. It's important to note that the tag is just a label used to match the jobs in our CI pipeline with available runners. It doesn't need to be matched the executor type or have any technical linkage. We simply refer to this tag in our, let me show. We simply refer to this tag. Here we can see we have referred. We simply refer to this tag Docker in our gitlab-ci.yml file to ensure that the pipeline jobs are picked by the correct runner. And here the Docker as executor means each CI job runs inside a clean Docker container. It ensures isolation, uses any image we define, and keeps builds consistent and reproducible. So let's select Docker as executor, hit enter, and here now we will define this image. Let's copy, Control C and paste it in here using Control Shift V. in terminal. So here we will define this image using which our CI job will run inside a clean Docker container. This will keep our builds, here you can see, this will keep our builds consistent and reproducible. And let's go back to the project repository, and instead of the config folder, Docker file, here we can see the Docker file for the image, for this image, the Docker file. This holds all the necessary installations for running our CI pipeline. We haven't built and pushed the image to Docker Hub yet, but we'll do that before triggering the CI pipeline to deploy our applications. So here select this image, hit enter, and this completes the runner registration. Now let's start. Here you can see choose an executor. We have chosen. Now let's start and run the runner using this command. Let's copy the command in terminal. We'll paste it in here using Ctrl+Shift+V. Now we'll use sudo along with this command also to start and run with the default root user as said before. Hit enter, and at this point the runner should be up and running. Now we can safely exit this terminal process using Ctrl+C. So let's verify it using GitLab, using the command gitlab runner status. This confirms that the service is active and running. Now we'll use this command gitlab runner verify. Let's use sudo along with it, sudo gitlab runner status. Same, this confirms the service is active, and sudo gitlab runner verify. Here we can see this shows that the runner is properly registered and ready to accept and execute CI/CD jobs. Now let's check in GitLab also. Here we can see it's also showing that our runner is currently active and ready to accept and execute CI/CD jobs. Let's view the runners. Nice, here you can see our runner is online currently. Now we need to update the GitLab runner configuration file config.toml to apply the required correct settings. Let's make the changes first and then we will go over what they mean. And for that we'll type sudo nano /etc/gitlab runner /config.toml, and this will open the config.toml file with the editor nano. Let's provide the password. Here we can see the config.toml file, GitLab runner configuration. Now we will edit to apply the required correct settings. Here under runners.docker, turn this privilege is equal to false to true, true. and then under of disable cache, here you can see volumes is equal to /cache. Replace this line with this block. Let's remove the line first, volumes, and then have copied with Control C. Now we'll paste using Control Shift V. Fix the indentation. Now it's okay. So we have replaced the previous old volumes line using this block, network mode and also volumes. So here let's now talk what we have changed. We set privileged is equal to true, so our runner can use Docker in Docker to build and run containers. Then we set network mode is equal to host to allow the runner to access services on our local network like Minikube. And finally we mounted Docker socket and our Kubernetes and Minikube config folders so that the CI jobs can run Docker commands and interact with our local Kubernetes cluster during deployment. So now let's save the file with Ctrl+O, press enter. It's saved. Now exit with Ctrl+X. So we have successfully updated our GitLab runner configuration file config.toml to apply the required correct settings. Now we can run GitLab CI/CD, but before running that we need to do some other one-time manual task. Here are the tasks that we need to perform: adding the CI/CD end variables in GitLab, then creating project access token in GitLab, then cloning the project from GitLab into a local machine, then setting the Git remote origin for pushing the code from a local machine to the GitLab, then initializing Minikube environment before pushing the code and triggering the CI pipeline for the automatic deployment of our project. So let's start with the first one, add the CI/CD end variables. To add the CI/CD end variables, here for this project, let's close this one and keep one tab. To add CI/CD variables here for this GitLab project, the variables are listed in the text file called CI/CD end variables.txt under of the config folder here. So let's quickly add these CI/CD end variables for the project, and before we add these variables we need to consider these things which are added here in the heading section. Let's copy the text from here because we can't read from here properly. We'll paste the text in here in our notepad. Now from here we will read. We can set the visibility to masked to hide the variable, which will avoid printing the variable to the CI/CD pipeline logs. If we keep the visibility as default selected, which is visible, then it can be revealed to the CI/CD pipeline logs. But when visible, if the project is private, then there shouldn't be any issue. And if we find issue to masked the variable, then we can increase the character length to 8 or more to fix the issue, if it is possible. So then the variables which are used, most of them are default credentials for the respective services. So we'll have to be careful here when we want to change any variable from here, we can get access issues later after port forwarding. So we'll have to keep in mind these things while adding the CI/CD variables. Now let's go ahead and add these variables one by one. And for that, under settings, we will go to CI/CD, open with new tab, then expand variable section. Now here we will add the variables one by one. Let's add the variables. Add variable for the first one, mail password. This will be the key, then password is the value. Let's mark the variable. The value length is 8. Now we can mark the variable. Let's add the variable. The variable has been successfully added. We can see protected, marked, expanded. Now let's add the second one, mail username. Key will be mail username, then value will be Jason Smith. This is of length 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Character length is 9. We can mark this variable. Now let's add the variable. Variable has been successfully added. Now for this one, Mongo init root password. Let's copy. Now add it as key, then password. This is of length 1, 2, 3, 4, 8. Value will be password, and as the length is 8, we can mark the variable. Now let's add the variable. Variable has been successfully added. Now Mongo init root username. We'll add it as key, then value will be admin. Now we can't mark the variable. This here we can see unable to create marked variable because the value must be 8 characters. So we'll have to keep it visible. Now it can be an issue if the project is public, because the value can be revealed to the CI/CD pipeline logs. If the project is private, it won't be any issue. So we can proceed here. Let's go ahead and add the variable. Variable has been successfully added. Now pgadmin password. Key will be pgadmin password, and this will be admin. Password will be admin. This is the default password, so we cannot change this right now. We need to configure if we change, and we can't mark the variable. If the project is private, it won't be any issue for the exposure instead of the CI/CD pipeline logs. So we can keep it visible. Now let's add the variable. Now pgadmin user. Key will be pgadmin user. Value will be admin@example.com. Let's add the value. Now we can we? Yes, we can mark the variable because length is more than 8. Now if the characters contain $, then this can create issues. Then we'll have to unselect this one, expand variable reference, because $, will be treated as the start of a reference to another variable. That can create issue. So if there's any $, inside of the characters value, we'll have to unselect this expand variable reference. Now there's no, so we can select the expand variable reference. Keep select the expand variable reference. Variable will be marked add variable. This was pgadmin user, then Postgres DB, key will be Postgres DB, value will be users. We can't mark this variable, it will be visible. If the project is private, it won't create any issue for the exposure of the value. Let's add the variable. Variable has been successfully added. Now Postgres password, key will be Postgres password. This is the default password for Postgres password. This is of length 8, character length is 8. Now we can mark the variable, add the variable. Variable has been successfully added. Now for Postgres user, key will be Postgres user, then value will be Postgres. This is the default Postgres username. Now marks the variable 1 2 3 4 5 6 7 8, length is 8. Now you can mark the variable, add variable. This was Postgres user. Now for the user email, admin@example.com, value. This is the user email. We can mark this variable as the length, character length is more than 8, add variable. Now the last one, user password, will be user password, and use the base64 encode from the below password to encode the user password in base64 in terminal. We'll have to copy this one and paste it in our terminal, hit enter, and we'll have to copy the output. This is the base64 format of this password, hashed password. Let's paste it in here. Now let's fix the indentation issue. Now let's copy. Now let's go to, we will get something like this in output, then set the output as the value. Now this will be the value, base64 format of the hashed user password. Now we can mark this variable, add variable. So is there any remaining? No. So we have successfully added all the n variables here for this on-prem Go microservice app project. Now let's go for the second task. Let's go for the second task to create project access token. The access token for this GitLab project is needed to set the remote origin for local Git and is also needed as the password while running the CI pipeline for the automatic deployment of our application. So to create the access token, let's go to access tokens from under the settings. Now here is the old one. Let's delete this old one and we'll create a new one. We'll name it, this is on-prem Go microservice, on-prem Go microservice app token. The name will be, then expiration date from now it will be 1 month most probably. Yeah, it is expiration, duration is 1 month. Now let's provide the developer role. Now let's select all the scopes for the developer role. Create project access token. So the project access token has been successfully created for this on-prem Go microservice app project. Now let's go for the third task, clone the project. we need to clone this project on-prem Go microservice app and have the application code on our local machine so that we can push it from our local machine and trigger the CI pipeline. So let's quickly do that. First let's collect the access token, otherwise we can't copy it later. If this disappear, then we can't copy later. Access token, let's paste it in here for on-prem Go microservice app token. So we have copied and saved. Now let's go to let's go for cloning the project. Click on code, clone with HTTPS, copy the HTTPS URL. Now open up terminal. Now let's set the path where we want to clone the project. CD, let's copy it in our documents folder. Now let's paste, type git clone, paste the HTTPS URL. So this will clone our project into the system's documents folder. Let's hit enter. Cloning 59%, 96, 100. So the cloning is done. Now let's open VS Code, open folder, documents. Here you can see our on-prem project which we have just cloned, on-prem Go microservice app. Let's open it. Add, yes, I do trust my GitLab account. So we have successfully cloned the project in our local machine. Now let's go for the third task. This will be the fourth task. Let's go for the fourth task, set git remote origin. We need to configure the remote origin for our local Git repository using access token we generated earlier. This will allow us to securely push our code to GitLab. So let's go ahead and set that up. Open the terminal, integrated terminal of VS Code with this project using Ctrl+J. Now type git remote set URL, then origin. Now let's go to GitLab, and for this project let's copy the clone with HTTPS URL again. Now let's go to VS Code. Now let's paste that cloning URL, HTTPS URL in here after origin. Now we need to provide our access token after HTTPS clone / before GitLab. Let's copy our generated access token from here for the project. Now let's paste the access token in here. Now after the access token, before of GitLab, we will provide @ so HTTPS clone / our access token, project access token, then @ then gitlab.com. Now let's hit enter. So it is succeeded. Now so we have successfully configured the remote origin for our local project. Now it's time to go for the last one, the last one-time manual task before pushing our local code to GitLab and trigger the CI pipeline for automatic deployment of our project. So initialize Minikube environment. So let's go for it. We will initialize the Minikube environment for preparing the Kubernetes cluster, ensuring it's ready to receive and manage application deployments triggered by the CI/CD pipeline within our local server. So let's initialize the Minikube environment with the command minikube start -driver will be docker, then -memory will be 4096, almost 4 GB, then CPUs will be CPU cores will be 2. So let's go for it. So our Minikube environment has been initialized. You can see our Minikube environment has been initialized with the specified memory and CPU limits. Now let's check the Minikube profile. Minikube profile list. Here we can see the Minikube has started with the Docker driver, so that the Minikube node can run as a Docker container, which will act like a virtual machine with the help of our Linux servers OS kernel. And we will also be able to run Docker containers of our app services inside of this Minikube node, which runs as a Docker container. Here we can see creating Docker container. So Minikube node is running as a Docker container. Now let's check the status. Minikube status. Here we can see the node name Minikube, type control plane, host running, kubelet running, API server running, kubeconfig configured. So everything is okay, which is nice. Now let's enable an add-on called Ingress by Minikube add-ons enable Ingress to have an Ingress controller within our Minikube environment. It's enabled. You can see the add-on is enabled. Now let's check the status of the controller by qctl get pods -n namespace will be ingress engine x. Hit enter. The ingress controller is running, we can see, without any issue, which is nice. Now let's enable another add-on called dashboard. Minikube add-ons enable dashboard. Enter. So the dashboard add-on is enabled now. Now to monitor our Kubernetes cluster and app resources, let's open the dashboard in our browser with Minikube dashboard. Nice. We can see the dashboard. Currently there's nothing. Once we deploy our application, we will have a full functional dashboard here, by which we will be able to manage our app resources like we can do with the kubectl client from our terminal. So we will check that later after deploying our application. And one thing here is, don't exit this terminal session until we want our dashboard, this dashboard, to be alive. So with this we have successfully done all of these listed tasks, manual task. Now before triggering our CI pipeline, let's quickly review, the contents. Let's quickly review the contents of our .gitlab-ci.yml file. Here we can see we do have a Docker image tagged as runner tools. It's the second version, we can see, including the test and scan dependencies for this project. And instead of the config folder, here we can see the Docker file for it. So with this Docker file, we are going to create the runner tools. We are going to create the runner tools image and then going to push it to the Docker hub, which we are going to pull later during our CI/CD pipeline run. So it's going to provide us with the necessary tools and packages which are necessary to run the CI pipeline. Then we do have 4 different stages: build, test, scan, and deploy. For the build, test, and scan, we will have the necessary Docker files included in each relevant service folder. Here we can see for the authentication service, there's a Docker file. For the broker service, Docker file. Front end, Docker file. Listener, Docker file. Logger, Docker file. Mailer, Docker file. So we will have the necessary Docker file included in each relevant service folder for build, test, and scan. And at last we will have the deploy stage, which is going to deploy our application by deploying config ktest, by deploying this config ktest. This ktest configuration manifest files for each relevant app services. And if we open the authentication YAML file, we will be able to see here we have used the environment variables in the ktest files, and with the other YAML files where needed, we have used the environment variables, CI/CD environment variables. Here we can see. So we have used the environment variables here in the ktest files, which we have defined in GitLab as CI/CD n variables, and now we are going to fetch those environment variables during our CI/CD pipeline before deploying the ktest configuration files. And then we are applying the ingress file. Here we can see app ingress. So we are almost ready with everything. Now we need to build and push this Docker image. This is the Docker file to Docker hub, and then we can push our code from here GitLab to trigger the CI/CD pipeline. So before triggering the CI/CD pipeline, let's first build and push this Docker image for having the necessary runner tools during the CI/CD pipeline run. So let's build and push. Close this. The Docker image is inside of the config folder. So let's open the config folder in terminal. Now we will use these 2 commands for building the Docker image and pushing the Docker image to the Docker hub. And before that, let's first ensure the login to Docker hub, Docker login, authenticating with existing credentials, username, login succeeded. So we have successfully already logged in to Docker hub. Now let's copy this command from the heading section of the Docker file and paste it in here to build this Docker image. So the image has been built. Now let's push the image to Docker Hub using this command. Let's copy it and paste it in here in terminal with Control Shift V. And also the built image has been pushed to Docker Hub. Now let's check it. In here, let's refresh. Here we can see. Here we can see the runner tools image less than a minute ago. It is pushed, the image is pushed in here, and here this is our Docker Hub account to which we logged in before we built and pushed the image in here in our Docker Hub. Here in this terminal, we logged into Docker Hub, then we built and pushed the image. So this is our image which has been pushed here less than a minute ago. Runner tools 1 minute, and the tag is 2.0.0. So we have successfully built the runner tools image and pushed it to Docker Hub here. Now the GitLab will be able to fetch this image during the CI pipeline run. Now if we remember, we had created a GitLab runner in our GitLab and then configured it in here in our local server. So with that in mind, let's finally push the code from here, from our local machine to GitLab, and trigger the CI pipeline. Let's close this terminal. We need this terminal. This is the CI pipeline. Now we have already set the remote origin. Now we will, to trigger the CI pipeline, to push the code from here, we will need to modify the code. Let's hit and enter here in the gitlab-ci.yml file. Now we can push the code. Git add all, then git commit m modified gitlab ci file to trigger the CI pipeline. Commit and then push. Let's push the code. Push. Now it will ask for password, which is the generated access token for this project, which we collected before. Now let's copy this access token and paste it in here, then hit enter. Nice. Here you can see the code is pushed. Now let's monitor the pipeline, triggered pipeline from here, from GitLab. Here you can see authorized 1 minute ago, the commit, and the pipeline has been triggered and running. Let's monitor it. You can see our pipeline, all the different stages: build, test, scan, deploy, where the build job has already been started with 1, 2, 3, 4, 5, 6 different segments. Let's wait until it finishes all the tasks assigned. Pulling the Docker image. Job succeeded. Go back. Refresh. Build job for the authentication service is done and succeeded. Broker service, build job for broker service has been successful. All the segmented builds are successfully done. So the build job has been successfully completed, and meanwhile the test job has started with 6 different segments. Let's wait until it finishes all the tasks assigned. All the segmented tests are successfully done. So the test job has been successfully completed. And meanwhile, the scan job has started with 6 different segments. Let's wait until it finishes all the tasks assigned. So all the segmented scans are successfully done. So the scan job has been successfully completed. Now the deploy job has started. So the deployment job is also successfully done. Here we can see the files are deployed, created. This should be done. Yes, it is done. So here we can see the build job is done, test job is also done, scan job is also done, and finally the deploy job is also done successfully. So the full CI/CD pipeline has been successful. So now we can test our app locally with an insecure HTTP connection once everything pods, services, and ingress function and run successfully without any issue. Now, before checking the application resources, let's quickly take a look at the Docker images built by our CI/CD pipeline in our local environment. Let's do that. Open a new tab in terminal. First run Minikube sh to securely access the Minikube environment. Now use the command docker images to view the images built by the CI/CD pipeline. Here you can see all the images, all the built images during our CI/CD pipeline run. So this allows us to verify and manage the images directly from here within this local Minikube environment. Now we can simply type exit to leave the environment. Now let's quickly check the current Kubernetes context. kubectl config current context. By default, we are using the Minikube context since there are no other configured context at the moment. Now, if we ever need to switch context, we can first list all the available Kubernetes context by kubectl config get context. We just have one Minikube context currently, you can see. So after listing all context, we can switch to the Minikube context using kubectl config use context, then Minikube context, copy, paste, like this way, switch to context Minikube. Here we are already using Minikube context, so currently there's no issue with accessing our application resources from our local Minikube environment using kubectl. So now let's check the status of our app resources. We'll open up a new terminal, or we can check this from here also. Kubectl get svc for services. Let's maximize the terminal. Now we can have a better view. Here we can see all the services of our app. Cluster IP, the broker service type is node port, and also the front-end service type is node port, and the others are cluster IP. So this is nice. Now let's check the pods status. Kubectl get pods. Nice. Here we can see the pods are running fine without any issue. 1 by 1, 1 by 1, 2 by 2, 1 by 1, 2 by 2, 1 by 1. All pods are currently running without any issue. Now let's check the status of our ingress. So we get img. Nice. Here we can see the ingress has been assigned an external IP, which should be the same as the Minikube node IP. Let's check that. Kubectl, not kubectl, it will be Minikube node Minikube IP 192.168.49.2. Nice. Here we can see both IPs are same. So the ingress assigned external IP is the same as the Minikube node IP. Now we can check this status of our app resources from the Minikube dashboard also. Here we can see our Minikube dashboard is currently active, running in our browser. Here's our dashboard. Nice. It's already showing the deployments, pods, replica sets. You see deployments, pgadmin, Postgres, RabbitMQ, Mailhawk, Mongo. All the deployments are here. For the workloads, if we see the pods, here you can see the pods running. Then let's see the services. Here you can see the services, front end, node port, and cluster IP. Then there should be another node port for the broker. Next page, here we can see broker node port. Then see the ingress. Here you can see the app ingress, external IP, which is the Minikube node IP. Then the domains. So now we can manage all the resources from here using this dashboard like we can do with our kubectl client from the terminal. We can check this dashboard functions and all the resources from the dashboard by taking proper time later. So everything is now okay with our app resources. Now we just need to do one little thing before we access our app, and that is we need to edit our host file to point our domains, these domains, to the ingress assigned external IP, which is the Minikube node IP. So let's quickly do that. We will type sudo nano to open with the editor nano, then /etc, then host. Now we'll provide the password. Here we can see our host file. Now let's quickly edit host file. So our Minikube IP or ingress IP, ingress assigned external IP ing, is this one, 192. Let's copy it. Control Shift C. Now in here, let's paste it in here. Now space, then main domain micro svc, which is our app domain, micro svc.net. We can copy it from here also. Let's copy and paste. Then space, then the subdomain for the broker service. Copy and paste. So it is correct. Now let's save the file using Ctrl+O, then press enter. It's saved. Then exit with Ctrl+X. Let's check the file again. Here you can see the file has been saved. Let's exit with Ctrl+X. Now we can access and test our app locally with the insecure HTTP connection. So let's access the apps domain in our browser, local browser. Here, paste and hit enter. Nice. Here we can see we can now access our application with our apps domain locally with the insecure, not secure, here we can see with the insecure HTTP connection. If we copy and again paste it in here, we will be able to see this is the HTTP connection. Let's hit enter in here. Here we can see it's redirected to the Microservices.net. So we can access our application locally with the insecure HTTP connection. And let's check the functionalities. Test broker, nice. Test RabbitMQ, test okay. Test auth, nice. Test mail, test RPC, test gRPC, nice. So all the functionalities are also working fine without any issue. So our application is working fine. Now it's time to deploy and validate the HPA, horizontal pod autoscaler, with our application. So let's quickly do that. We will find the HPA config file. It will be in here under of config folder. Here you can see the HPA config file. Instead of the config folder, let's copy the path of the config folder. Now let's go back to the terminal. In here, let's set the path of the config folder. cd paste. Have navigated to the path. Now let's deploy the file by kubectl apply -f, then HPA config YAML, hit enter. So the HPA for all the services are created here, we can see. Now let's check the status by kubectl get HPA. Here we can see the HPA is now active and functioning. Now before validating the HPA and after that installing the monitoring stack, we will have to ensure there is a metric server and it is running and functioning properly. We already know what a metric server is. Metric server is a lightweight Kubernetes component that helps monitor cluster performance by collecting resource usage data from nodes and pods and enables features like auto-scaling. Now let's quickly have the metric server in our Minikube environment by enabling the metric server add-on. And we'll do that by Minikube add-ons enable matrix server, hit enter. Nice, here we can see the matrix server add-on is enabled. Now we can check the list of all the enabled add-ons so far by Minikube add-ons list. Here we can see the add-ons which are enabled: storage provisioner from Minikube, matrix server from Kubernetes, ingress from Kubernetes, default storage from Kubernetes, dashboard from Kubernetes. So these are the enabled add-ons. Now let's check the status of the matrix server by kubectl -n, then kube, then system, then get pods bitwise or, then grep, then matrix. Nice, here we can see the status is showing one by one. Pod is currently running, means the matrix server is currently running and functioning properly. Now we can check the server's resource usage, especially CPU and memory consumed by our application components by kubectl top nodes. This shows the overall CPU and memory usage of the node running our cluster. Now kubectl top pods. This displays the CPU and memory usage for each running pod associated with our application. You can see. And now we can also validate the HPA scaling behavior by applying concurrent load to the application. For this, we can use the test auth button, since it triggers a relatively heavier container, making it easier to generate noticeable load quickly. So let's go ahead and test it. Test auth button. Let's make some concurrent request by using this test auth button. We are concurrently clicking on the test auth button. Response, getting response. Now this should be enough here. Now let's check the HPA status by kubectl get HPA. Here we can see the CPU usage are increasing for the authentication service already. Get HPA. Here you can see, nice. It was using one replica. Now the replica number has been increased to 4. Here we can see. Check again. So the pods for the authentication service are now increased to 4, means the HPA is functioning properly. So now we can monitor the server's resource usage, and also can monitor the HPA scaling by the help of our newly configured metric server. Now that we do have our configured metric server and our application is also running smoothly with HPA scaling in place, we can move forward and deploy the monitoring stack. So let's run this Python script. Can be found under task before after CI/CD folder. So let's run this Python script to deploy our monitoring stack. This Python file is going to deploy this monitoring Helm chart for deploying our monitoring stack. So let's quickly run the file according to this heading section. Before running the script, let's quickly check and ensure that we do have Python 3 installed on our machine or not. We should already have Python 3 pre-installed on our Ubuntu LTS by default. Let's check and ensure. Terminal Python 3 version. Nice. Here you can see we do already have Python 3 installed on our Ubuntu LTS. Now let's run this Python script according to this heading section. cd my file path, and this is the Python folder. Let's copy the path. Let's cd and navigate to the path. We are inside of the task before after CI/CD folder. Now we can run the file with this command Python 3 and the file name. This is not the file name, correct file name. This will be 1, then install Prometheus Grafana Py. Now the file name is okay. Now we can run the file using this command Python 3 and the file name. Paste it in here. Now let's hit enter. Starting updating Helm dependencies. So the file execution has been started. Let's wait until it finishes. Starting installing or upgrading Prometheus and Grafana. So the script ran successfully and the Helm chart was deployed. We can see that it's showing the first revision, confirming that the deployment was completed. Now let's check the status by kubectl get all-n monitoring. It is installed in the monitoring namespace. Now the pods are not running. Here you can see the pods are not running successfully yet. Now we will be checking the pod status only by kubectl get pods -n monitoring. Container creating. We'll be checking the status, pod status. Now once this one is remaining only, these two are remaining, this one and this one. Now only this one is remaining. 2 by 3, one pod still needs to be running. So all the pods here you can see 3 by 3, 1 by 1, 1 by 1, 1 by 1, 1 by 1, 2 by 2, running. So all the pods are now running successfully. Now it's time to deploy the ServiceMonitor for our monitoring stack. So let's go ahead and do that. In our project code, the ServiceMonitor should be inside of the config folder. Here we can see the ServiceMonitor config.yml file. Now we'll set the config folder path, copy path. Now instead of the terminal, let's type cd, then paste the path. Now we are inside of the config folder path. Now we can deploy the file called ServiceMonitor config.yml, and we will do that by kubectl apply -f, then service. We'll hit tab to autocomplete. Now let's hit enter to deploy. Service monitors are created. Let's check kubectl get service monitors. kubectl get service monitors. It is probably in the monitoring namespace. Monitoring. Let's check. Yeah, instead of the monitoring namespace, the service monitors are deployed. So let's hit enter. Nice. Here we can see all the service monitors which we have just deployed for our application services. Now at this point, our monitoring Helm chart has been successfully deployed. All the related pods are currently up and running, and the service monitors have also been created. We can now access our fully functional monitoring stack in the browser with Prometheus and Grafana. Now let's quickly update the host file first, like as we did before while accessing our app. So we'll type sudo nano /etc/host. We'll provide the password. Now under of this record, we'll provide another one. Copy, and here we'll keep this Minikube node IP or our ingress assigned external IP here, and then we'll modify these two domain names for Prometheus and Grafana. Prometheus.microservices.net, and then another subdomain for Grafana will be grafana.microservices.net. Now we will save the file with Ctrl+O, then press enter. It's saved. Then we'll exit with Ctrl+X. Let's check again. Yeah, it is successfully saved. Now we can access and test our monitoring stack locally with the insecure HTTP connection. So let's go ahead and do that. Let's check kubectl get ing-n monitoring. We are checking the ingress for our monitoring stack. Here's the ingress, and the IP is the same. So this is the Minikube node IP. Now we'll copy the subdomain for the Prometheus from here. Now we'll come in here and paste it in here. HTTPS HTTP continue to site. Nice. Here we can see we can now access Prometheus. And now let's check for the Grafana also. Grafana net copy paste, not secure, continue to site. Nice. Here you can see we can also access Grafana with the insecure HTTP connection. Now let's provide the default username and password. That should be admin and prom operator, PROM, prom hyphen then operator, OPERATOR, prom operator. Login. Nice. So we can access Prometheus and Grafana, and in here in Prometheus, if we from the status and go to targets, let's clear the selection. Nice. Here we can see the necessary service monitors for our application services. The necessary service monitors are currently up and running, means it's correctly scraping metrics for the Grafana dashboards. If we go to dashboards from Grafana, here we can see the default dashboards for Grafana. So the default dashboards here, let's check workloads. Nice. Here you can see, so the default dashboards are currently functioning correctly, and the custom dashboard should also perform correctly here in Grafana. Let's import and see documents, then that should be config, Helm chart, files, app, matrix JSON. Let's select this one and import. Nice. Here we can see the custom matrix dashboard is also working. We need to create some metrics for instrumenting this dashboard. So this is working currently, which is nice. Now after configuring the alerting rule, here with this application metrics dashboard, custom application metrics dashboard, we will receive notification in Slack also. So our monitoring stack is working as expected. So here everything is working as expected with our local setup. So with this we are done with our local setup. Now it's time to expose our application to the internet with Cloudflare so that we can access our application globally with secure HTTPS connection. So let's quickly start the process step by step. First, let's install Cloudflare in our local server. So open a new terminal. Now let's install the Cloudflare. We'll find the command install Cloudflare. Cloudflare Zero Trust. Here you can download the install Cloudflare via Cloudflare package repository. Let's open this link, and here any Debian based distribution recommended. For our Ubuntu, we'll select this. Let's copy all these commands. Now let's go back into our terminal and paste here to install Cloudflare. Hit enter. Now let's provide the password. Now let's check the version. Cloudflare version. Nice, here you can see the Cloudflare version, which means we have successfully installed Cloudflare in our local Linux server. Now let's go to our domain provider. Squarespace domains for our case. Manage domains. Have already signed in. Now Microservices.net for the overview. Now go to DNS, and under of DNS settings, here under of DNS settings, ensure there's no custom records. We can see we don't have any custom records, which is fine. And this is important because we'll have to add custom records to Cloudflare and have to use DNS servers which they prefer. Now access the local server's host file. In our terminal, sudo nano etc host, and in here also ensure there's no custom records. Means we have to remove the records which we have added so far for the main domain and subdomains with Minikube node IP. So this is important because the custom host entry bypasses DNS resolution. If we leave it, the browser will keep resolving the domain to the local IP address directly, skipping Cloudflare, which means we won't be able to verify whether the HTTPS connection is working properly through Cloudflare secure tunnel. So we'll have to remove these records. Let's go ahead and do that. Now let's save the file using Ctrl+O, then hit enter. It is saved. Now we'll exit with Ctrl+X. Now let's check that again. Yes, the file has been successfully updated. Now let's exit with Ctrl+X. So we have successfully removed all the custom records from our local server's host file. Now, before we move forward to achieve a secure HTTPS connection with Cloudflare, we need to update our front-end service deployment file. Here's our front-end service deployment file, and here we can see we are using insecure HTTP broker URL. So now the secure HTTPS, this one is the secure HTTPS broker URL. So the secure HTTPS URL is needed here for the broker URL. So let's uncomment this secure one and comment this insecure one for the broker URL. Now let's deploy this file using our terminal. Let's set the path of the KTest folder, inside of which we do have our front-end deployment file. Copy path, back into the terminal, cd, paste the path. So the KTest folder path has been set. Now let's deploy the front-end file, front-end deployment file by kubectl apply -f, then front-end YAML. Hit enter. You can see service unchanged, but deployment is configured for the front end. Now let's check the pod status by kubectl get pods. Here we can see the front end service deployment is created 18 seconds ago and is currently running without any issue. Now let's move forward to achieve the secure HTTPS connection with Cloudflare. So for that, let's go to Cloudflare website in our browser, https //www.cloudflare.com. Here's the website for Cloudflare. We are going to use their free plan. We are going to use their free plan, which is sufficient for us to expose our app to the internet securely. Before we go to start for free, let's compare the plans quickly and try to see what's included in our free plan. Compare plans, and here you can see free, pro, business, enterprise, free 0 per month. Now let's see. Here we can see in our free plan you will have fast, easy to use DNS, unmetered DDoS protection, CDN, universal SSL certificate, free managed rule set, web application firewall, WAF. So all the main things we will have in our free plan. Now we can compare all features and check things by having proper time. So we can check this later. Now let's go back and let's go to start for free. Continue with Google. Here we can see we have landed on the account home page, which means we already do have an account with Cloudflare. If we don't have any account here, we can just sign up and create an account like this, and after that we will auto land on this account home page. Now from account home page, let's add our domain, registered domain, which is microservices.net. We can add from here domains. Now enter an existing domain. Let's enter our domain and keep this as it is. Quick scan for DNS records recommended. Now let's continue. Select plan for microservices.net. We are going to select free plan. Here you can see unmetered application, layer DDoS protection, IP-based rate limiting, protect against high severity vulnerabilities, WAF, detect challenge common bots only, universal SSL certificate, free to use, easy to use DNS, global CDN. So every basic things we are going to have with our free plan. So let's select this one, select plan. Now review DNS records. This is okay. We don't have currently any DNS record. These are the domain's default records for name servers, and this is for domain connect. We will add later. Now let's add later from our terminal before we start our tunnel. Now let's continue to activation. Last setup, update your name servers to active Cloudflare. Now we will follow the instructions here. Log into your DNS provider most likely. Now we have already logged in here. Now find register and lookups DNS provider. Make sure DNSSEC is off. DNSSEC, it is off. Now replace your current name servers with Cloudflare name servers. So we'll have to delete the other name servers which are there in our Cloudflare, and we'll have to replace those with these two. Now let's quickly do that. Domain name servers, here's the default name servers for the squarespace.com Squarespace domain. Now let's use custom name servers, which will auto delete this for two name servers. Copy first one, then second one. Now save. So the two custom name servers have been applied here. Now let's continue. Here we can see this registers take up to 24 hours to process name servers change. Quicker in most cases. We will email you when microservices.net is active on Cloudflare. Now we should receive an email once our domain is activated. We should receive it usually within a minute or maximum up to 24 hours in some special cases. So let's wait, let's see what it takes, and meanwhile let's quickly complete the other task. Now from our local servers integrated terminal, here log into Cloudflare using the command cloudflare log in. Hit enter. Nice, it is working. Now on the form status invalid name servers, the name servers are not activated yet. Once we receive our email, activation email, we will see the status active here. Now let's to authorize, on the form of authorize Cloudflare tunnel, click anywhere on the row containing the domain listing. Now let's authorize. Success. Cloudflare has installed a certificate allowing your origin to create a tunnel on this zone. You may now close this window and start Cloudflare tunnel. Close this window. Now let's see, we have successfully logged in. Now we can use Cloudflare tunnel once we receive our domain activation email. Now add the required CNAME DNS records for the added domain in Cloudflare. Let's add, maybe we have received our, yes, here we can see, nice, microservices.net is now active on Cloudflare free plan. So our domain is now currently active and the added name servers are now applied to our domain. So refresh here, see. Here we can see the status is currently showing active, and let's check the status of the activation from the, it is not needed now, from the overview page. Let's refresh here. Here we can see it is showing the active status alongside with our domain in the overview page. And here we can see the SSL-TLS. Let's go here to see the status of our SSL certificate. Overview, we can see. Now go for the S certificate, and here we can see our SSL certificate. The status is active, the type is universal, and here the certificate is applied for our main domain and also for all the subdomains. This is the wildcard domain, and the certificate is managed, which means managed by Cloudflare, which means after the expiration it will be automatically renewed and managed by the Cloudflare itself. Now let's go to account home, and here we can see it is showing the status active along with our domain. So our domain is currently active. Now let's quickly validate our domain's global availability and its applied name servers from a website called DNS Checker. DNS Checker, DNS lookup, Microservices.net. Let's look up DNS. A record, no, okay. Here we can see name servers, Microservices.net, Cloudflare.com. So these are the two name servers which we have added to our domain provider. So these are now currently globally available and applied to our domain, and our domain is also globally available. So everything is okay here. Now let's quickly create a Cloudflare tunnel called Microservices tunnel, and then add the required DNS records. So we'll create the tunnel named Microservices tunnel first using Cloudflare tunnel create Microservices tunnel. Let's hit enter. So we have created the tunnel successfully. Here we can see this is the tunnel path, and Cloudflare choose. So the tunnel has been created. This is the ID. Now we will add the required CNAME DNS records in Cloudflare to route traffic via the created tunnel. So let's quickly do that one by one. Cloudflare tunnel route DNS Microservices tunnel, then the main domain Microservices.net. Let's check Cloudflare tunnel route DNS Microservices tunnel Microservices.net. So this will add a CNAME DNS record for our main domain with the Cloudflare tunnel. Let's create the record. So we have added the record successfully. We'll check in Cloudflare our created CNAME DNS record after we create all the records from here. Let's create the CNAME record for the broker subdomain. Cloudflare. Oh, we can get the previous command. Now let's broker.microservices.net. Have added the CNAME record for the broker subdomain. Now let's get the command and do the same for www. Have added the CNAME record for the www subdomain. Now for Prometheus. microservices.net. Have added successfully. Now for Grafana. Have added the record successfully for Grafana. Now let's check and validate. From here, let's go to the domain overview. Now go to DNS. Nice, here we can see the added records. This is for our main domain microservices.net CNAME record, then broker microservices.net CNAME record, then www CNAME record, then Prometheus microservices.net CNAME record, then finally Grafana microservices.net CNAME record. So all the CNAME records, required CNAME records, are added to the Cloudflare. Now we'll go for updating the configuration file, config.yml file for Cloudflare. And for that, let's open a new terminal so that we can find the necessary information. Here we can see the file path ID, so later when needed. Now we'll first, for updating the configuration file, config.yml file, first find Minikube IP, Minikube node IP, which is needed. Minikube node, find it in here, Minikube IP. This is our Minikube IP. Now let's create Cloudflare configuration directory. Sudo mkdir, then p, then etc, then Cloudflare password. So the directory has been created. Now let's update the Cloudflare configuration file finally here in new terminal tab with sudo nano etc Cloudflare config YAML. Here we can see the old records which we have added before are still here. So this part of the records here, ingress, then hostname, then service. This is the Minikube IP. Let's check 192.168.49.2. So it is the same, so it is okay, and the domain, main domain, and all the subdomains are the same. So this part of our config YAML file is okay. We don't need to change or check anything here. These are okay. We need to check this one is valid or not here. Home. So let's copy the credential file from here and compare that with this credential file. Let's paste it in here and check. Home. no, it's not the same. So let's replace the credential file with this one. With the new one which we have just created by creating our Cloudflare tunnel. Now let's save the file with Ctrl plus O, press enter, it's saved. Now exit with Ctrl X. Now let's check again. 30BF 30BF BF30. So it's successfully saved. Now we have successfully updated our Cloudflare configuration file. Now let's quickly add a redirect rule in Cloudflare to redirect from www to root. Let's go to Cloudflare and go to, here we are in the overview. Yes, now domain overview. Now from the domain overview, let's go to rules, and in here under overview we will go for the templates, and here we will select this template, redirect from HTTP to HTTPS, and we'll select this template and create a rule. Now we'll rename this rule with redirect www to root, and the default selection will be as same as it is, wildcard pattern. Now for request URL it will be HTTPS then colon slash then www.microsvc.net then slash then asterisk. So let's check HTTPS colon www.microsvc.net slash asterisk. So this is the request URL. Now let's set the target URL, HTTPS colon slash then microsvc.net then slash then the $ and curly braces 1. So let's check that again, HTTPS colon slash microsvc.net slash $ curly braces 1. So it's okay. This is the target URL and this is the request URL, and the status code will be 301. And let's check the preserve query string. Check this. Now let's deploy the rule, redirect rule. Deploy. Nice, here you can see it is active. So we have successfully created our redirect rule for redirecting from the www subdomain to the root or main domain. Now finally let's start the Cloudflare tunnel. Let's go back to our terminal here, and in here let's open a new terminal, or we can run. Let's open a new terminal. Let's start and run our terminal by Cloudflare tunnel, Cloudflare tunnel, run, then the tunnel name, which is micro svc tunnel. Let's hit enter. Nice. So there's no issue, and we have successfully started our Cloudflare tunnel, which is running currently. Now keep this terminal session running to keep the apps domain accessible via Cloudflare. Don't close this. So now we'll be able to access our app and monitoring stack with the secure HTTPS connection. So let's access and test the app and monitoring stack with secure HTTPS connection. Open the browser. Let's close the unnecessary tabs from here. Open a new tab. Now we'll access the apps domain first, which is microsvc.net. Now let's hit enter. It should be redirected to the HTTPS microsvc.net with secure connection. Let's hit enter. Nice. Here we can see it is redirected to our apps domain is redirected to the HTTPS microsvc.net, which is to the secure connection. Here we can see connection is secure. This is nice. Now let's test the functionalities. Test broker. Nice. Hit broker. Nice. Nice. So all the functionalities are also working as expected. Now let's check the redirect from www to root, our main domain. Let's type the subdomain microsvc.net. Now it should be redirected to our main domain with secure connection. Nice. Here we can see it is redirected to our main domain with the secure connection. Connection is secure, and all the functionalities will also work as expected. Now our apps domain and the redirecting is working as expected with the secure connection. Let's check our monitoring stack. Let's first check the prometheus.microsvc.net. It should be redirected to the secure HTTPS connection. What? Not secure. Let's type https clone / then https, then nice. Now it is okay. So we can access our Prometheus with the secure connection. And here if we go to status and then targets and then clear the selection, nice. Here we can see the service monitors, necessary service monitors for our app is up and running. So it is scrapping the metrics from our application. Prometheus is scrapping the metrics from our application. So everything is okay here. Now let's access Grafana. Let's nice. So Grafana subdomain is redirected to the secure HTTPS connection. Here you can see the connection is secure. So now let's check dashboards. Nice. Here you can see the default dashboards, and the dashboards are working as expected, which means it is collecting the system metrics and instrumenting the system metrics into the dashboards. Now default dashboards. Now these are the default dashboards from Grafana. Let's import a custom app metrics dashboard, which is inside of our project folder, then config, then Helm monitoring chart, then inside of the file, then app metrics dashboards. Let's import this one. Okay, now import override. Nice. Here we can see the dashboard is working. The custom application metrics dashboard is working. So the dashboard, Prometheus is scrapping metrics successfully, and our Grafana is using that metrics and collecting the metrics from Prometheus and instrumenting the metrics into our dashboard, Grafana dashboard, default dashboard, and also the custom dashboards. So the Grafana and Prometheus is also working with our secure HTTPS connection. So now our application, the redirect from www to the root domain and the full monitoring stack all are working as expected. Now at this point, as both our application and monitoring stack are globally accessible and running securely over HTTPS, with that we have successfully completed the entire secure on-premises setup we set out to achieve. Now, before wrapping up, let's briefly cover these three final points related to our on-premises setup. The first one is deploying multiple applications on a single host machine on the same on-premises setup. Then some quick words to talk more about Cloudflare, the second one. Then the third one is on-premises versus cloud platforms like AWS or GCP. So let's go for the first one, this first one, which is deploying multiple applications on a single host machine on the same on-premises setup. Let's go to our browser and GitLab On-Prem microservice app. You can see here's another project which we are going to use to deploy as the second project on our single host machine on the same on-premises setup. We can see we already have it pushed on our GitLab for this setup. It is called On-Prem microservice app. If we saw our previous videos on cloud and DevOps, then we definitely know about this one, and also we have given a brief about this project at the starting of this video. So we are going to use it here for deploying as the second app on our on-premises setup. So let's quickly deploy this second project on our same single setup. And for that, here we can see we do have the gitlab-ci.yml file for the automatic deployment. Here we have used the same image, runner tools, second version. The second version is almost the same as the first one, but includes the extra dependencies used in the test and scan job. So as this project doesn't include any test and scan job, just build and deploy, it's referred to use the first version when we deploy this project alone on a single on-premises setup. But for now, we are not going to change the version because we want to use the same runner for both of the projects. Now in our terminal, let's access the runner config which we have right now using sudo nano /etc/gitlab runner, then config toml, provide password. Here we can see we have used this image for our previous Go project for the runner config. So we are not going to change this one right now, as we can continue with this for our man stack project also, which we are going to deploy right now. So we can use a single runner for both of the project deployment. Let's exit the terminal. Now to deploy this project, within our single on-premises server, let's quickly clone it into our server or local machine so that we can push again here in GitLab to trigger the CI pipeline for the automatic deployment. So let's do that. Code, clone the HTTPS URL. Now let's open terminal. Now we will clone it inside of the documents folder. Our first app, which is our Go app, is also there inside of our documents folder. cd documents. Now git clone. So done. Now let's open the project with VS Code. Here's our first app code, which is on-prem Go microservice app. Let's close these files. Minimize. Now let's add folder to workspace. On-prem Go, on-prem man, add. So this is our project, second project. Now before we go for deployment of this project, we just want to create a new namespace, and for that, in here, instead of the gitlab.ci.yml file, we will add creating namespace. We can see we are already creating the namespace here, so we don't need to include anything extra. So we are creating man app. This we included while we tested this CI pipeline. So let's move forward. So this will have to include inside of our CI pipeline to create a new namespace before deploying our Kubernetes configurations and application. Now the namespace will be created after running the pipeline, and after this we want to deploy all these KTest configurations, which is inside of our config folder, inside of the KTest, all these KTest configurations inside of a new namespace, which is this one, which we will create with our CI pipeline. This is man app, the namespace name. Let's copy the namespace name. Now open the file. Now under metadata section, we will provide the namespace name, namespace, then colon, then this is the namespace. Now we'll do the same. This is for the deployment. We'll do the same all for the service also. Now we'll do the same with the others. Let's quickly do the same under metadata. metadata namespace, then the namespace man app is already included here inside of our app ingress YAML. This we included while we tested the project within our single on-premises setup for deploying this as the second application or project. So we have modified all the files with the namespace to which we want to deploy the second project. Now we do have another task remaining before going for the deployment of this second project, which is inside of this index file. Here we can see we have used a subdomain named man app for our main domain microservices.net to expose this second app to the internet. So now we do need to first add a CNAME DNS record for the subdomain in Cloudflare. Let's quickly do that. Let's add a CNAME DNS record for the man app Cloudflare. We can copy the command from here. Paste. Now just modify the subdomain section, which will be man. Let's copy from our ingress file man app. Now let's add the CNAME DNS record. So the CNAME DNS record for the man app subdomain has been successfully added. Let's validate that from the Cloudflare. Here DNS man app. Here we can see nice man app microservices.net. So the CNAME DNS record has been successfully added to the Cloudflare. Now we need to update the Cloudflare configuration file to add a host name for the subdomain. Let's do that using sudo nano etc /cloudflare config YAML. Now in here we will add a host name for our subdomain. Copy the subdomain. Create a new entry. Now man app, this will be now it is okay. Now the custom record for the man app subdomain has been added. Now we can save the file. Control O, press enter. It's saved. Now exit with Control X. Let's validate. Yes, it is saved successfully. Now we'll be able to deploy all of the app resources to the new namespace called man app, and all the app resources of our Go app, previously deployed app, will be in the default namespace, which were there from before, and the monitoring stack of that Go app will be in the monitoring namespace, which were there from before. So this is nice to have the resources segmented in the separate namespaces. This way we can easily access and manage different application resources without any confusion, each within its own dedicated namespace. Now we will go for deploying this second project on our on-premises setup. Let's quickly create an access token Here in GitLab, we'll go to settings, then access tokens for on-prem microservice app. Yes. Now let's add new token. On-prem, we'll name it as on-prem microservice app token. Select role, we will select the developer role. Now we will select all the scopes for the developer role. Now let's create the project access token. So our project access token has been created successfully. Now let's copy the token and store it in here. This is our on-prem Go microservice app token, and this is our on-prem MERN microservice app token. We saved the token. Now let's set the git remote origin using our access token in our local machine so that we can push to trigger the pipeline. On-prem, let's close these files. Now to set the git remote origin using the access token, we will type git remote set URL origin. Then we will copy the project's HTTPS URL. We copied. Now in VS Code we will paste it in here after origin. Now we will copy the access token for our second project, MERN micro app project. Now we'll come in here. Now we'll put the access token after https:// we'll put the token after // Control Shift V to paste. Now after the token, before of gitlab.com, we will put @. So this is now okay. Now we can set our git remote origin. So our git remote origin has been successfully set. Now let's deploy this second app on-prem Go microservice app from our local machine to GitLab and trigger the CI pipeline for the automatic deployment of this project on our single host machine on-premises setup. So let's quickly do that. We'll add the code to the git updated git add all, then git commit modified, updated the code to create and add new namespace to create new namespace to deploy the app resources to that new namespace. Okay, let's commit. Now git push. Now we'll provide the password. We'll copy the access token, paste it, Now hit enter. Now the code has been pushed. Now let's see here. Let's refresh the browser, and here we can see our pipeline. It's currently pending. It should be triggered. Okay, you can see the job is stuck because on of the following problems, there are no active runners online. Okay, I know the issue. Let's go to the project, and first let's cancel the pipeline. Cancel pipeline. We haven't enabled the GitLab runner for this project. Let's go to settings, then CI/CD, then runners. Here we can see enable for this project. The GitLab runner, this GitLab runner is enabled for our Go Microservice app project, but it is not enabled for this project. Let's enable this. Enable for this project. Runner assigned to this project. Here we can see it is showing disable option to disable. Now we can run the CI pipeline and run and trigger and run the CI pipeline. So we'll have to push the code again. To push the code, let's hit an enter inside of the gitlab-ci.yml file to provide a new line. Now it is modified. Now we can push the code again to the GitLab to trigger the pipeline. Git add all git commit modified the GitLab CI file to trigger the pipeline. Git push. Let's copy the access token, paste it in here, push, pushed. Now let's see what happens. Nice, here we can see the pipeline is running. Right now it is not stuck. So the pipeline has been triggered already. Now let's monitor the build job, pulling Docker image. Let's wait until the build job finishes and complete all the tasks assigned to it. Job succeeded. So our build job has been completed successfully. Let's go back and go to the pipeline again. And meanwhile, the deploy job has also been succeeded. So with this, our full CI/CD pipeline has been successful. Now let's check the app resources in the different namespace. Here inside of our terminal, let's clear the terminal. Now kubectl. Let's first check our app resources inside of our default namespace for our previous app, first app, Go Microservice app, and then let's later on check the app resources for our second app, which we have just deployed. Kubectl get pods. This is inside of the default namespace. We could also run like this -n then default. So for the default namespace we don't need to provide any namespace name. So these are the pods for our Go microservice app. First application which we deployed previously are running fine. Then let's check the services. As we see, services, then ingress. So these are the main app resources for our first microservice application which we deployed previously on our single host machine setup. Now let's check the app resources for our second app which we have just deployed. kubectl pods -n. Now we will have to provide namespace because it is not the default namespace. Man app. Let's check. There is dash. Let's copy the namespace name. Okay. Now let's go back to terminal. Here we can see running one by one running, then container creating, pending. So we can access our app resources in a different namespace called man app. This is for the pods. Now let's check the services. Okay, now we can access the services. Now app, now ingress. We can also access the ingress of our second app inside of the man app namespace. So this is nice that we can now access and manage all the app resources having a different namespace. Now let's check the pod service status again. Here we can see these pods are pending, container creating. Let's see what's the status of the pods and service. Here we can see the RabbitMQ service which is of type load balancer is pending. Ingress is okay. Now let's see again those are resolved or not. kubectl get pods and man app. Here we can see these three pods are not running, these are pending. The age is 24 minutes, so this should already be running. There's definitely an issue, and that's why these are in pending state. Now let's also check the service. Here we can see the RabbitMQ load balancer is pending, so we definitely have a issue there. Let's try to find the issue. We will describe the pod and see what's the issue. Let's open a new terminal. Now let's describe the pod. kubectl describe pod name, then -n, then namespace name is man app. Here we can see warning, failed scheduling, default scheduler, 0/1 nodes are available, 1 insufficient CPU. Okay, 1 insufficient CPU. So there's a CPU limit we do have. Let's check the another pod also. So we do have insufficient CPU, and for this reason, due to our current hardware limitations, we won't be able to deploy multiple applications in this setup. Let's go to the settings. and find system and then about, and here's our basic hardware configuration we can see, which we saw before also. Now to overcome our current limitation, this limitation, we can upgrade our host machine's resources, particularly by increasing the RAM to at least 16 GB, and most importantly using a higher end CPU with 8 or more cores. Our processor currently have 4 cores, so we need to upgrade a higher end CPU with 8 or more cores. So we can consider the upgrade options available on Ryan's website, which we referenced earlier in this video. By boosting the server's memory and processing power, we'll be able to overcome this constraint and successfully host not just 2 but multiple applications on the same on-premises setup. Now let's go for the second one to talk more about Cloudflare. So far we have used, let's go to Cloudflare. From Cloudflare, so far we have used Cloudflare tunnel, DNS, SSL certificate and redirect to root services to expose our application to the internet securely, and those were all in the free plan, but we don't know how it's further protecting and providing security to our application with some security modules along with our secure tunnel, which are also included in our free plan. So let's talk about that. From Cloudflare here, from the domain overview page, let's find the security section, then under overview, dashboard, this is the dashboard for the security. Now then there's analytics for the security, you can see. Now let's go to settings. From here we'll be able to see the security modules. These are the security modules. So from here we'll be able to see the security modules or the services which are here for us with the free plan and are sufficient to secure our application at the basic level. We can see here is web application exploits, stop the newest threats including zero-day attacks with Cloudflare's machine learning powered security. So this module will prevent our app from the newest threats out there on the internet. Then there is DDoS attacks. So we already know what DDoS attacks are. A DDoS attack happens when many computers send too much data to a website, causing it to crash or stop working. Hackers control these computers using viruses to do the attack. So this is how the DDoS attacks happen. And here is the DDoS attacks module, detect and mitigate distributed denial of services DDoS attacks across the network and application layers automatically. So this module will prevent our app from the DDoS attacks across the network and application layers automatically. Then there's bot traffic, identify and mitigate automated traffic to protect your domain from bad bots, including scraping from the spam. So this module will protect our domain from bad bots, including scraping from spam. And then there is API abuse, secure your API endpoints and get recommendations and insights about your endpoint usage. So this module will secure our API endpoints. Now, then there is client-side abuse. Keep track of your application's JavaScript dependencies and configure alerts for changes and malicious scripts. So this module will keep track of our application's JavaScript dependencies and will notify us about any malicious scripts. So these are the security modules. Now we can see this one is currently active. You can see 2 available detections. So this one is currently active, and this one is also active, 2 available detections. Then this one is inactive. We can activate it from the manage detections, then by enabling both detections from here, enabling both detections, we can activate this bot traffic as well as per our need. Let's go back, and then we can do the same. As well for the other inactive modules as per our need. So these were the security modules and services which are included in our free plan. Now let's quickly go to access. Here, for launching the Zero Trust, we do need to provide payment details. It won't charge for the free plan, but the payment details for the Zero Trust is must for a strict validation. We have provided our payment details before, so now we can launch Zero Trust. Let's launch Zero Trust with a new tab. Select account. Now, before continuing further with the access, we'll have to create an application here from the applications. So let's quickly do that. Add an application. Self-hosted. Application name Microservices. Let's name it Microservices or On-Prem. On-premises. On-premises app. This is app. Session duration, keep it as it is. Now add public host name, domain microservices.net. These are optional. Now let's click on next. Let's click on next. Save. So we have created our application. Here we can see application URL, the name we provided, it is self-hosted. So the application is created. Now we can create policies. Here, instead of policies, add a policy. Policy name, let's name it block users. Then action will be block. Session duration, same as the application session timeout, or we can block for 15 minutes, 30 minutes, 6 hours, 12 hours, 24, 1 week, 2 weeks, 1 month. Let's select for 30 minutes. Now we can block any user by country or email, or we can apply some more configurations from here to protect our application's accessibility. Country. So this was a little brief. Then let's select country, select value. Let's select Bangladesh. Save. So we have successfully created users policy to block users from Bangladesh for 30 minutes. So this was a little brief about accessibility, and there's a lot more which we can do with our domain for providing secure access to our application. And here we can see there's a lot more options and services here in the zero trust also, as like the domain overview here we can see. And also there's some inside of the account home. So we can check these things later by taking proper time. So this was the brief overview of how Cloudflare further supports our setup by providing additional security protections and accessibility measures for our application. Let's move forward. Now let's talk about something very important about the last one, which is on-premises versus cloud platforms like AWS or GCP. This comparison will help us decide which is the right fit based on our project needs, scalability goals, and infrastructure preferences. So in this case, let's first talk about the on-premises setup. In an on-premises setup, we use our own physical server hosted locally. We have full control over the environment, security, and configurations. It's a great learning experience and ideal for custom, secure, or internal applications. However, it requires us to manually handle hardware, networking, scaling, backups, security, and maintenance. And this setup is best for educational purposes, self-hosted projects, high control environments. So this was about the on-premises setup. Now let's talk about the cloud platforms, AWS, GCP, or etc. Cloud platforms offer fully managed services, servers, databases, CI/CD pipelines, monitoring, scaling, all available on demand. They ensure high availability, built-in security, and automatic scaling with just a few clicks. We pay only for what we use, which is cost efficient for many production applications. However, for long-term usage at large scale, cloud cost can add up quickly. Now, cloud platforms are best for production-grade scalable applications, teams that want to focus on development rather than infrastructure, fast deployment with minimal overhead. So, which one should we choose? If we want full control or we are building something internal or experimental, we can go with on-premises. But if we want speed, reliability, and scalability without managing the hardware, cloud is the way to go. At the end of the day, it depends on our goals, budget, and the technical preferences. Both have their pros and cons, and understanding that helps us make the right decision for our project. So with this, we have now covered all these three final points that were related to our on-premises setup. Now we are just one step away from wrapping everything up. Before we conclude, we will perform a cleanup task, destroying all the resources that were created on our PC to turn it into an application server. To do this, we will follow the steps outlined in the text guide file. named manual on-time task after CICD.txt from the folder called task before after CICD inside of our on-prem Go microservice app project, which was our first project we deployed. And inside of this file, at the bottom here we can see destroying the resources created so far on our local PC. So at the bottom, here's the guide using which we will destroy all the resources created so far on our PC to turn it into an application server. So let's start with it to destroy the resources. First, we'll delete the Minikube environment. Let's copy this command, Minikube stop, to stop the environment. Let's close all the terminals. We'll keep just one terminal. We don't need terminal anymore. Now we can keep this one terminal. Now let's paste Minikube stop to stop the Minikube environment. Then Minikube delete. After stopping the environment, we'll delete the environment. Minikube environment has been stopped. Now we are deleting the environment. Have deleted the environment, Minikube environment. Now let's remove the Minikube folder from our system. It's removed. Now let's check the status. Profile Minikube not found. So there's no Minikube anymore. So we have successfully deleted the Minikube environment. Now we have deleted the Minikube environment. This will also delete or remove the entire Kubernetes cluster along with all the application resources within it. Means it will remove the whole Minikube environment, which includes Kubernetes cluster and the app resources within it, and also all the built images within it, which were created during the CI/CD pipeline run. Now that all the app resources and Minikube environment are deleted, now let's delete the build Docker images outside of our Minikube environment inside of our system. Let's copy this command to delete those images which we built for the runner tools more specifically. Paste. Yes. Here you can see the deleted images. Here's the runner tools image, and this is for GitLab runner. Now let's list the image, Docker image. There's no image we can see, so all the images are deleted from our system. Now uninstall the Minikube itself. We'll copy all the command and paste it in here to uninstall Minikube, which provided us with the Minikube environment and necessary tools to create our app resources. Now, and provide the password. Provide again. So the Minikube tool has been uninstalled. Now let's check the version. Here you can see no version found, which means the Minikube tool has been uninstalled successfully. Now let's uninstall Docker engine from our machine. Copy all the commands. So it's done. Now let's check the version of Docker engine. There's no version available, which means the Docker engine has been successfully uninstalled from our machine. Now uninstall kubectl, copy all these commands, paste. It's done. Now let's check the version of the kubectl client. No version. So the kubectl tool has been successfully uninstalled from our machine. Now it's time for the GitLab runner. First stop the GitLab runner. It's stopped. Now let's uninstall the GitLab runner. It's uninstalled. Now unregister all runners. We do have one, so this command will unregister that runner. Unregistered successfully. Now let's check the status of the GitLab runner by accessing the configuration file of it. Here we can see there's no configuration included, so the GitLab runner has been unregistered successfully. Let's exit by Ctrl X. Now let's verify GitLab runner. We can see there's no runner active currently. Now let's remove the remainings, GitLab runner folder, then etc folder, then so let's remove all the remainings for the GitLab runner. Removed successfully. So we have successfully uninstalled the GitLab runner. Now uninstall Cloudflare. Finally we'll copy all of these commands, paste. Yes, I do want to continue. It's done. Now let's copy the Cloudflare version command and paste it in here to check. No version found, which means the Cloudflare has been successfully uninstalled from our machine. So with this, we have destroyed all the resources that were created on our PC to turn it into an application server. Now that we have successfully destroyed all the resources from our on-premises setup, it's time to wrap things up. Since the entire process from the deployment to deletion can be quite time consuming, we have included all the necessary reference text files in our project's root directory to help streamline each step whenever needed. With that, this marks the conclusion of our setup. Hope this guide was helpful. Thank you.